Hello everyone, my name is Ashish Chaudhary. I am an associate professor at IIIT Bangalore and I will be offering a course on discrete mathematics. In this short presentation, I will be talking about the course overview, the learning objectives and the learning outcomes of this course. So, the first question is why this course, and the answer for this question lies in the answer of another question, namely what is the importance of strong foundation for a long lasting building. So, if you compare these two buildings, you can easily understand that it is very important to have a strong foundation for a long lasting building. In the same way, your foundations in computer science is laid through various core courses like discrete mathematics, data structures, algorithms and so on. So, what is computer science? Many people believe, especially in today's age, that computer science is all about coding and programming, but unfortunately computer science is not just about programming, or it is not just about software engineering, artificial intelligence, machine learning, cryptography, blockchain, etc. So, the famous Turing Award winner Dijkstra's once said that computer science is no more about computers than astronomy is about telescopes. So, what exactly is computer science? Computer science is all about problem solving. What is discrete maths? So, it is very difficult to come up with a precise answer for this question. So, on a very high level, it is a branch of mathematics which is devoted to the study of discrete objects, and by discrete object means objects which have well defined boundaries like integers or steps of an algorithm or distinct paths between two cities and so on. So, discrete mathematics provide you all the necessary mathematical background that you need for all your subsequent courses in computer science, and some of the problems which we solve and try to address using discrete mathematics are the following, namely how many ways certain things can be done. Say for instance, how many distinct IP addresses are possible, because as I said, discrete mathematics is all about the study of discrete objects which have well defined boundary. So, we will be interested to count them. In the same way, we may be interested to find out how many paths can be there between two computers in a network, or at the first place are two computers connected. In the same way, I can try to address questions like, is it possible for a computer to send message securely to another computer? What exactly is the length of the shortest path between two computers? How exactly we prove certain things and so on. So, all these questions we try to address using discrete mathematics, and this list is not exhaustive. So, typically the goals of any course in discrete mathematics are threefold. First, we try to do mathematical reasoning in terms of ability to read, understand and construct mathematical proofs. Since discrete mathematics is devoted to the study of discrete objects, a major focus of discrete mathematics is that on combinatorial analysis, where we study techniques for counting objects of different types. And most importantly, a course on discrete mathematics develop your ability to do algorithmic thinking, namely how exactly we model a given problem in terms of mathematical problem, mathematical abstraction, how exactly we analyze it and how exactly we proceed to solve the problem. So, to give you an example of the beauty of abstract thinking and the kind of problems that we will try to address in this course, let me give you this wonderful example. So, there was this famous mathematician who used to live in a city, and in his city there was a river flowing across, and that river divided the city into various islands. So, you have the island A, island B, island C and island D, and there were various bridges which connects these two various islands, and this mathematician used to go for evening walk every day, and one fine day he asked a question to himself that, is it possible to do a round trip covering all the bridges exactly once? That means, is it possible that I start a walk at any of the chosen islands and I cover all the bridges exactly once, that means none of the bridges are missed, and I end my trip at the same island from where I started. So, one way of answering this question would be that I try all possible trips that I can make in the covering all these islands and bridges, and then see whether I get an affirmative answer to my question or not. But the mathematician did not proceeded in that way. Instead, what he did is the following: he abstracted this entire problem, this entire scenario in terms of a picture, which we in today's jargon in computer science call as graphs. So, all the islands are abstracted as some dots here. So, you can imagine here that we have 4 dots, and the bridges connecting 2 islands are abstracted by lines connecting the corresponding dots, which in the jargon of graph theory we call as edges. And he basically reformulated his question as the following: he asked that is it possible to have an Eulerian cycle in this graph, and people who are familiar with graph theory, they will be knowing what exactly is Eulerian cycle. It is basically a trip starting from a vertex and ending at the same vertex, and which covers all the lines exactly once. And he actually came up with a necessary and sufficient condition under which it is possible to find out an Eulerian circle in a given graph or not just this specific graph, but in general it could be any graph. So, that is the way he proceeded to abstract this problem as a mathematical problem and try to solve it, and that is the kind of thing we will do in this course. So, if you are wondering who exactly was this famous mathematician, he was Leonhard Euler. So, the course syllabus is as follows: we will start with mathematical logic and various proof strategies. A major theme of the course will be on studying discrete structures like sets, relations, graphs. We will be doing a lot of combinatorial analysis in terms of studying various counting mechanisms. We will touch upon some various aspects of number theory like modular arithmetic and properties of prime numbers, and we will also discuss about abstract algebra, namely we will study groups, rings and fields. So, it turns out that even though abstract algebra is very significant, very important for computer science, there are lots of areas in computer science which uses concept from abstract algebra, but typically computer science students find it very difficult. They indeed find abstract algebra to be very abstract to understand, because they fail to see the applications of abstract algebra in a typical course in discrete mathematics. So, that is why what we will do is in this course we will see how the concepts from number theory and abstract algebra are used in some of the cryptographic applications. The course is a 12 weeks course, and we will be roughly having 2.5 to 3 hours of weekly lectures, and we will also have tentative weekly problem solving tutorial sessions, and these are the textbooks which we will be using for this course. Of course, there are plenty of other resources available online. A little bit about me: I am an associate professor at International Institute of Information Technology, Bangalore, and this is my personal home page. These are my academic qualifications. Basically, I am trained in theoretical computer science with specialization in cryptography, and I am teaching courses on discrete mathematics, cryptography and advanced cryptography over the last 6 years, and I also do offer a course on cryptography available on NPTEL. This is the link for this course, and that is all for the introduction. I welcome all of you for this course. Thank you.